Very good morning. Yesterday we have seen what are the different methods of collection of samples. If I recapitulate, okay, the first one is simple random sampling, just like that you pick up. Second one is stratified sampling. Okay, that means in that case, if the items are in large numbers or huge numbers, then we are going to divide that one, the entire lot into sub-lots, and from the sub-lots, again, we'll take the sub-samples, and all those sub-samples together, we call it as a sample. So at least 2 samples are to be taken from each of the sub-sample. Third one was systematic sampling. Because that is what the best application of this one is found in the testing of the cement or sheet metal like that. Okay, then the fourth method was, or the method we discussed was cluster sampling, almost same as stratified sampling. So it will be in form of clusters. That means things are available in the boxes, small boxes, and in that case, we will pick up randomly the different boxes, and once the box is picked up, 100% inspection is done. And the last one we discussed about was 2-stage sampling. Don't get confused with this 2-stage sampling with the double sampling plan. Okay, this is one caution. Okay, so in 2-stage sampling, almost similar to the cluster sampling, but having selected the cartons randomly, all the items in the selected boxes will not be 100% inspected. Again, one will take the samples out of it. Okay, this is what we have discussed. And we stopped that, and I told you that our main this thing is on operating characteristic curve. Because now we have seen how the samples need to be collected. Now sampling plan, in the sense, here we never talked about in sampling method how much quantity is to be or how many samples are to be taken. What should be the acceptance number or the rejection criteria or acceptance criteria? It was nothing discussed. So in sampling plan, it considers that. So actually in sampling plan, what is important is, one is lot size, because yesterday I told you that we are going to discuss about the terminologies used in the acceptance sampling. Okay, the terminology used in acceptance sampling, that is what we are going to discuss, and then we'll be discussing about the operating characteristic curve. Okay, this operating characteristic curve is dependent on the different types of sampling plans. That you need to remember. Okay, that's all. Okay, that gives, in fact, operating characteristic curve in the sense, anything, even if you look at how the electric motors are tested, that means maybe it is load, how much amperage it will consume, or how much HP it will develop, or how much voltage it will draw, and other things. That is operating characteristic curve. Similarly, the OC curve, it gives the comparison of different sampling plans. Okay, that is why it becomes inevitable for us to study about the operating characteristic curve. And to study about the operating characteristic curve, we should be conversant with some of the symbols that are being used, which I call it as the terminology. Okay, so the main terminology is, we are going to maybe some 7 or 8 First one is the lot size. The lot size is denoted by capital N. That means number of, because this is actually the thing which should have been inspected 100%. Instead of that one, that lot will not be inspected 100%. We will take the sample out of that lot. So how many samples are to be collected? It depends on the lot size. If the lot is big, or it may be medium, or it might be small. If the lot itself is small, then there is no question about the sampling. 100% inspection will be done. So here, major thing is the lot size is large. That we need to appreciate about those things. Lot size is large, so this capital N, it is large. The lot size is denoted by capital N. So our drive here, what we are going to learn is, we will collect some sample out of a lot of which consists of n items, which is a large quantity. Some sample size small n. From a lot of capital N, you collect a sample of small n. Say for example, lot may be around 1,000 items, 2,000 items, 10,000 items, like that. From that lot, I am going to collect the sample. So if the lot is 1,000 items, I might collect the sample of 50, or I might collect the sample of 25. That is what it means. Okay? So usually the sample size, it depends on the lot size. Okay. The next one we are going to consider is number of defectives. Defectives in the lot. We denote it by capital M. Try to understand. M denotes, because already you might be conversant, because when I discussed about different types of probability distributions, these things I have discussed. If the lot size is more, if the lot size is small, or sample size is small or large, like that. There also we have seen. And especially if it is to be, the probabilities are to be calculated, if the lot size is less, there we consider the number of defectives in the lot as well. So this one is capital M, it denotes number of defectives in the lot. Similarly, number of defectives in the sample, small m. What this one? So capital M denotes the number of samples in the lot. So if lot size is 1,000, if it consists of, say, some 10 defective items, so capital M will become that lot. Lot is, N is 1,000 there, M is 10. Then out of a lot of N, I collect a sample of small n, which I might be collecting around 50. So this 50, it will consist of some defective items, that I call it as the number of defectives in sample is equal to M. Suppose it consists of some 5 numbers. Okay, that is what, or it may consist of 2 number defectives. That is what we are just, when I take a sample, it is possible. Okay, out of 1,000 it may contain 10 defectives. Out of 50, it might contain 1 or 2 defectives. It is possible. Even perfectly possible, you say all the 10 might be there in that sample. Who knows? Okay, It's all probability. Okay. So that is what it means. Okay. Then why it is to be done? That gives us the other thing. What actually we are interested, I am interested in proportion of or fraction defective. I am interested in fraction defective. So now here fraction defective, how we will know fraction defective? How I will denote? Fraction defective, there are two things here. Try to understand, because this is very important, because if you get your all doubts clarified in these notations, there is nothing much in that, this acceptance sampling, the unit itself. That is why I want to make you to fully aware about this terminology. Okay? So fraction defective of the universe or the population. For all practical purpose for us, the universe or population for us is this lot. Try to understand. Lot size n, that is the universe or population which we want to test, or whether that lot is a good lot or bad lot, whether it should be accepted or rejected. That is the universe for us or the population for us. So fraction defective of the population or the universe, fraction defective of the population or the universe, we know already it is P prime. It is called as P prime. How it will be found out? If you know the number of defectives in the lot and size of the lot, then we can find out this fraction defective. That means what? This P prime is equal to what? Number of defectives, that is capital M, divided by total number of the items, that is capital N. This the producer will be knowing. And when he maintains process control charts, he will have controlled the process with respect to this. This is the actual thing, real thing. But the problem is what? Okay, the manufacturer says that it is only 1% defective. But how to believe him? That is what I discussed in my previous classes. How to believe him? If you believe him, no need to go about these things. No need to check. But the question here is, if we don't have the belief, what needs to be done? Only way out is check it. That checking we call it as testing. How it is to be tested? All the things are to be done. That is one way. Here we are adopting the samples. We are taking some certain chance, certain risk. That is what it means. Okay, is it understood? Now, the fraction defective or the population P prime, that is what he claims, who manufacturer. Okay, now fraction defective of the sample, we denote it by P. Try to understand. Fraction defective of the sample. That means I have taken a sample of the small sample size of small n, and it contains the number of defectives is equal to small m. That means is equal to P is equal to what? Small m by n. It is as simple as that. Okay? And if I take like this number of samples, then that will become average sample fraction defective. What is one? The difference. This is the fraction defective of the sample. Average. Now, average fraction defective of samples. This is equal to what? How many samples are taken? For each sample, I am going to find out P. That means P1, P2, P3, P4 like that. Likewise, I might have taken 10 samples. So divided by 10. That means that is its average. That is what we are already conversant, because when we discussed about the control chart for attribute, especially P chart. Similarly, that how that P bar was found out, same thing. You must be aware of that. The same thing, that means it is P bar. It is denoted by P bar. Okay. Maybe this P bar might be the best estimator of P prime. Okay, fine. Okay. These are number of samples, that the average fraction defective of the samples. Okay. Now, next important thing is, I take a sample of N out of lot size of capital N. Okay, then I will try to find out how many defectives are there. Then I need to have certain criteria. If it consists of so many defectives, if it contains more than these numbers, I will reject it. That is what I told you. So, for example, the producer claims that out of 1,000 items, the 50 are, or the out of the 1,000 items, no, it is 5% defective. 5% defective means how many? 10% defective means 100. 5% defective means 50. Okay? Or he might say that it is 1% defective. Try to understand. He claims that 1% defective. Okay, out of 1,000, it will consist of only some 10 defectives. Under these circumstances, what I can do? Okay, I will decide to take a sample of some 50. Out of 50, I want that it should not contain more than one defective. If it contains more than one defective, because I will take a sample of 50 from a lot of 1,000 and I will count, I will test those 50. So it will, if it contains more than one defective, then the entire lot will be rejected. How did I fix this? One, that we call it as acceptance number. What this one? One is acceptance number. That means acceptance number, usually it is denoted by C. That means this accept number is what? It is maximum allowable number of defectives in the sample. C means what? This is the acceptance number. This denotes the maximum allowable number of defectives. I said 1. More than 1, the lot gets rejected. Less than 1, because the only way out is that sample may contain 0 defective or 1 defective. That is the crux of it. Or say, if I decide C is equal to 2, that it should not contain, when I take a sample of 50, it should not contain more than 2 defectives. If it contains, it may contain 0 defective, yes. It may contain 1 defective, yes. Then also the lot will be accepted. Even if it contains 2 defectives, yes, the lot will be accepted. But if it contains more than 2 defectives, it will be rejected. More than 2 in the sense what? It will be an integer, only 3, 4, 5 like that. And it cannot contain less than 0. And no fractions. Got this one? So this, the acceptance number C, it might be greater than or equal to 0, but integer values. Okay, this is what is called as acceptance number. Next one, we say probability of acceptance. Probability of acceptance. Is denoted by PE. What is the probability that that lot will be accepted? Based on what? Based on the sample. That is why we talk about that. So, these things are to be defined. What are to be defined now? Important. Based on the lot size, we will decide the sample size. And based on the sampling plan, the acceptance number will be decided. And again, these all things will depend on the whatever the fraction is defective or the P prime value he claims, manufacturer. So, that's why the lot of thinking, lot of research work has gone into this one. So, it has been presented in the form of the table or the chart. So, if the lot size is so much, say between 1000 to 2000 or 2000 to 3000, like that, they have carried out the research work. And based on that one, they have said what should be the sample size, what should be the acceptance number. Okay? So, it is sufficient to at least know about this one. So, what is the probability of acceptance? Because that is what we can estimate. For these things, probability of acceptance is required, which can be calculated. Okay? Depending upon the sample size, that is small n, and the fraction defective. Okay? That is, it depends on that. Okay? So, what is the probability of acceptance? Probability of acceptance of the lot is 95%. Means what? I can write P.95 is equal to 2%. Means what? If the lot has got 2% defective, then its probability of acceptance is 0.95. P100. If it contains 0 defective, 100%. So, as the defective, it increases. Okay? As it increases, what will happen? Probability of acceptance, it should go on increasing or decreasing. It will go on, probability of acceptance, it will go on decreasing. What this one? This is what the operating characteristic curve should tell us. How it behaves. That means OC curve is nothing but the curve which will tell us the relationship between the probability of acceptance, because this probability of acceptance, it depends on the fraction defective of what? Of the lot. This is what? Probability of acceptance of the lot. Along the x-axis, it is fraction defective of the lot. As the fraction defective increases, what should happen to the probability of acceptance of the lot? It should go on decreasing. Okay? That is what is depicted by this operating characteristic curve. Okay? It is nothing but, it tells us the relationship between probability of acceptance versus fraction defective. I have given the name as operating characteristic curve. So this curve will go on differing depending on the value of capital N and N and C. Try to understand. It will depend on these three factors. So what is the significance of the OC curve then? Now I am interested in comparing different sampling plans. What do you mean by different sampling plans? Because we need to question ourselves like this. Okay? Say, for example, if I say N is equal to 100, small n is equal to 5, C is equal to 2. Means what? From a lot of 100, take a sample of 5. If this sample 5 consists of 2 or less than 2 defectives, accept the lot, otherwise reject the lot. It is as simple as this. Okay, I can go on how it will look like. That means I should go on drawing this curve. Okay? It will behave differently. Suppose N is 50. So I'll give these different examples. Try to understand this one. Try to compare. So you can learn many things out of it. Capital N is 50. Small n is 5. C is 0. This is one sampling plan. Another one, N is equal to 100. Small n sample is 10. C is 0. Third one I'll consider, N is 250. N is small n is 20 and C is 0. I could have put this one 25 if I want. Okay. N is 1000. Small n is 100 and C is 0. Okay. What is that I have done? You just look at the proportions. And C values I have put it constant 0. So lot size when it is 50, 10% of that one is taken, that will be the sample size 5. Here lot size is 100, 10% of that is 10. Lot size 250, 10% of that one is 25. That one I am taking as the sample. And here it is 1000, the 10% of that one I will take it as a sample, 100. Then how it will look like? Which is more better? Is it going to behave in a similar way? Say for example, if I look at this one, and then it might be behaving like this. Let us say, this is capital N is equal to 50, small n is equal to 5, and C is equal to 0. What about this one? N is equal to 100 and other things. Again it works out to be same? No. So it will behave like this. So as the sample or the lot size increases, the proportions I have kept same. But this one, it will behave like this. Because I'll be more sure. Try to understand. By taking more samples, I'll become more sure. So it distinguishes that. That is how it looks. Okay? Then you might start wondering, Why it is in the curved form? Why not some straight line forms? That is another question you need to ask yourself. So try to think in that way. Okay? Then only you will understand the subject. Now I'll make you to understand. Say, a lot is there. The customer, the manufacturer says that it contains 2% defective. He says, he claims that. Then customer, what will do? Yes, one way is what? Okay, I will check all the entire lot. If it is 2%, it contains 2% defective, I will accept the lot, otherwise the lot will be rejected. Okay? That means, say, let us assume the lot size is 1000. Lot size is 1000. That means how many defectives it should consist of? At the most, 2% defective means 20 defectives. I will count. If it exceeds more than 20%, the 2%, lot will be rejected. If it is less than 2%, it should be accepted. No other distinction. This is what is going to happen in case of this is when it will happen, when the 100% inspection is there. Entire thing is to be inspected. So if we draw the OC curve for that, how does it look? Let us see. This is the probability of acceptance of the lot. This is fraction defective P. Okay? What are going to be the starting point and what is going to be the ending point? Let me see. Okay? It is not necessary that the scale has to be same in both directions, not necessary. So this is 0, 0. Now you just think, probability of acceptance. It varies from which value to which value? That means, what is the probable value, probability, what is the scale for probability? We know that it will vary from 0 to 1. It will never exceed 1. At the moment, it will be 100%, only that much. Figuratively, we might say, I am 200% sure. Mathematically, we are wrong. Yeah, I am minus 200%, I am sure that it will not happen. Mathematically, it is wrong. It will be 0% or 100% or in between values. That means, if I represent here, maybe in percentage wise, whatever you can think. Because probability of acceptance can be expressed in percentage wise or fraction. So that means it is going to take 0 to 1 or 0 to 100%. And percentage defective, can it take negative value? Can it take more than 100 or more than 1? No. All the defectives, out of 1000, all the defectives are, all the items are defective. At the most 1 or 100% defective. Here also, it varies from 0 to 1 or fraction defective, or it might be 100%. Whatever you can think, you can put it over here. Now I said 2% because, okay, I cannot draw it to that this thing. Let us assume that the 2% is somewhere here. Okay? So this our 100% it will go somewhere there. Let us not bother. Now I said 2%. It should be accepted. If it is less than or equal to 2%, it will be entire lot will be accepted. Otherwise, it is rejected. And how it will look like? See, I'll draw and then try to compare. This is the thing. You know, If it contains 0%, what is the probability of acceptance? 100%. If it consists of 0.5%, 1%, 1.5% defective, 1.75, up to 2%, entire thing will be accepted. If it consists of more than 2%, rejected. No question. So I will have here only two reasons. This is the acceptance reason. This is rejection reason. Anything above than this? No. All the lots, if it consists of more than that, reject. Understood? This is the thing. This is the ideal situation. This is ideal situation in the sense when we go for 100% inspection. But we are not going for 100% inspection. Then why we cannot go for 100% inspection? In the previous class we have discussed about it. That is why we go for the sampling procedure. So there is no point in repeating about it. Okay, then I cannot adopt. Now I have to go for sampling. Then what? Then I need to have certain compromise. What this one? We need to have certain compromise. It doesn't mean that one thing is sure. I am sure. If it consists of 0% defective, then 100%